Hi, this is Mr. Merrill, and I'm going to walk you through what you need to do for the NetForce video analysis. So you need to have Logger Pro open, and you need to have downloaded the video from Moodle. So once you have Logger Pro open, you can just go ahead and delete everything that appears by default. And we're going to go to Insert, Movie. It'll likely be in your Downloads folder unless you told it to save somewhere else. And then to begin the process here, we're going to click in the bottom right where it says Enable Disable Video Analysis. We're going to select this chart and delete it. We don't need it for anything. And then we have to do a couple things to get this set up. First, click this top arrow, double click on the frame. We need to change this to advance 2 frames, and we also need to click this box to start the time at 0 with our first click. So if these two aren't set, you won't get the correct data points. Hit OK. The next thing we need to do is set a scale. Tell the software how large things are in actuality. So we can just draw a line, the length of this meter stick out in front. That is actually 1 meter, so we want to keep it in units a meter and click OK. The next thing we want to do is set an axis. So we're going to click this third option down that says Set Origin. We're going to mark the position of the cart by this little sticker here. Now you're going to have a different video with force towing the cart. This is just an example. So we go ahead and click there, and then we want to tilt our axis so that the axis lines up with one of the directions of acceleration. So to do that, you click and drag this dot to the right, and that will tilt the axis up the ramp like that. Okay, once that's set up, we're basically ready to add our points, so click the second option down to add points. And this is going to be quite a bit of clicking, but basically every time you add a point, it'll advance a frame, and you need to click in that center dot again. And you'll have to do that until the end of the video. This is the most tedious part, and I'll probably fast forward here. Okay, I will mention that you do want to be as careful as possible when adding those dots. It really does affect your data a lot if you're not accurate in doing that. So once you have all those dots placed, you're at the end of the video. You can go to Page, Add Page, go ahead and click OK, then Insert Table. And you'll get this table here. You can click to drag it. And we basically want to get rid of everything except for this column that says X. So we can click on the Y column, hit the delete button, click on the X velocity column, hit the delete button. Those are very inaccurate. I'm not doing it to give you more work, I'm doing it because if we use those default ones, you won't get a very good graph. So now we want to take this position versus time data and generate a velocity versus time set of data. Now before I had you do that by hand, I'll remind you how you did that. For the wheel analysis, you found the velocity at mid times by finding the average velocity between 2 times. So for instance, you could take this second data point for X, subtract this first data point for X, and then divide by this second time minus this first time. And that would give you the average velocity between 0 and 0.0667 seconds. And that average velocity between those 2 times is the same as the instantaneous velocity at the mid time. So we want, instead of having to do all that all by hand, because that is very tedious as you remember, there's actually a way to have Logger Pro do that for us as well. So to generate that new column, we want to go to Data, New Calculated Column. We're going to call this New Calculated Column Mid Time. And it's still T. It's still measured in units of seconds. And to generate this calculated column, we want to take some time, so for instance 0.667 seconds, and subtract half the difference between the previous time. And it might not be clear to you how to do that right now, but you can go to this function delta, And that will find the difference between the previous time point. So this says take 0.667, subtract the difference between the previous time point, so that's also 0.667, so we don't want it to be 0, so we want to subtract half the difference. So this will take 0.0667 minus half the difference between those two times. And if you've done it correctly, you'll see in this new mid-time column, all the times in the mid-time columns are halfway between the times in the time column. So you can actually follow it like this, 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 and you can run through that, and these times are always halfway between the two times. I wish there was some way to insert it in this new column, but there's not, so we've got to deal with this. Okay, so now that we've calculated the mid times, now we just need to find the average velocities between those 2 points, and that will be the actual velocity at those mid times. So we'll go to Data, New Calculated Column. We'll call this Velocity X, because it's velocity in the X direction. And short name, we'll just say Vx. And this is going to be measured in units of meters per second. So to make this column, the average velocity is just the change in x, or delta x, divided by delta t. And if you, the one way you can check to do this, to see if this is calculating it correctly, just go ahead and do one or two yourself to make sure you get the answer that you expect. So the idea is that we took this number minus this number divided by this number minus this number, we would get the average velocity between 0 and 0.667, which is the same as the instantaneous velocity at 0.33. So these are all paired up. Okay, so one last thing, we want to actually make this graph. So we want to go to Insert, Graph, and there's only one thing we have to do here. You see this is still at the bottom here on the horizontal axis, so still saying time, but remember these velocities match up with our mid times. So I'm going to double click on that and change this from saying time to saying mid times, and you'll see that it will shift the graph over, otherwise it should look exactly the same. Okay, and if you have a line like this, I don't really like the line like this, I would change it, so double click, and then instead of saying connected points, you can put point symbols, because that's how you would graph if you were graphing by hand. Okay, so the last part that you want to do here is find the slopes of these three different segments. So for instance, if we want to find the slope of this segment, on your video, this first segment runs to 0.6, so you'd want to highlight all the way up to there. But just this first segment, until it gets to the peak there, that's when it's being pulled up the hill, or in my video it's pushed up the hill. That gives you the acceleration during that segment. And we can make this whole graph bigger if you want, by just clicking on one of those arrows there. And then highlight this next segment. That goes all the way to when the velocity changes direction. So this segment represents it rolling up the hill. Nothing's pushing it or pulling it. Again, hit another linear fit button. And then finally this last segment when it's rolling down the hill. And we have a different negative acceleration here, and we can go ahead and find it. So it's a little obnoxious with the amount of lines going on, but at least it allows us to calculate those different accelerations. Okay, so finally we want to actually have a hard copy of this graph, so you would go to File, Print. You can add a title to it, so this is your velocity versus time graph. And you could add your name. And then if you print that out, it'll give you a hard copy of the velocity versus time graph to do the rest of your lab with. Okay, hopefully that helps. Just email me if you have any questions. Thanks.